So today in this video, we are going to see the next method, how we are going to check an integer is odd or even. So we have seen the brute force naive approach, which is a modulus method. Now we'll see how we are going to check an integer is odd or even using the least significant bit. So now let's go to the program. So before going to the program, we must know how we are going to convert an integer to a binary number. So for example, I'm going to just take a 75 integer. Now we have to convert the 75 into the binary number. So normally the binary values will be, what is the initial value it will start with is? It is 1. Then 2 to the power of 1 is 2. Then it is 2 to the power of 2 is 4. So then it is 8, 16, 32, 64, and 128. So why I have stopped up to 128 is here we are exceeding the limit of 75. So I have stopped up to here. So first, what is the value that we are going to consider is 64, right? So it will be 64 plus. So next step, what we are going to do is we have to subtract the value 75 minus 64. So what will be the value? It will be 11, right? So here, which one is exceeding 11? It is 8. So 64 plus 8 plus. So next what we have to do? We have to make it as 11 minus 8. So that is nothing but 3. So 2 is the exceeding one. So I have to write 2 plus. So again, what we are supposed to do? 3 minus 2. So that is equal to 1. So again, we have 1 here. Now if you check 64 plus 8 plus 2 plus 1, this will give you the value of 75. Okay, clear now? You can just make a check on this. 64 plus 8, that is 72. 72 plus 2 is 74. 74 plus 1 is 75. Hope. So now how we are going to write the value is, so we have the 64 value as 1. So we have to write 1. And we don't have the 32-bit value. So it is 0. And we have 16. No. So it is again 0. But we have the 8 value. So it is 1. 4 value we don't have. So it is 0. 2 value we have 1. And 1 also we have 1. Okay. So this is the binary value of 75. Clear? So 75 can be written as 1001011. So here this 1 indicates the least significant bit and this 1 indicates the most significant bit. So this is the highest value and this is the least value. So we are going to write the program based on this least significant bit. That is, if it is 1, the number is said to be odd. And if it is 0, then the number is said to be even. Clear? So now let's go to the program. So we have taken the classes whichever we have needed. We have imported the classes. So I have taken A as an integer. If it is the integer is converted to binary string and it is ending with 0, it will return the value as even, or else it will return the value of odd. For here, what I have taken is, I have taken the main method as iteration method, where I have taken A is less than or equivalent to 20. So what will happen? It will automatically iterate the values and it will print the result. So what we are supposed to do, we'll just open the command prompt. So what is the thing we have to do? We have to change the directory to workspace. So I have moved to workspace. So what we are supposed to do is we have to compile the Java program. So javac.lsb.java. So if there are no errors, a class file will be created and stored in your folder. So once it is compiled, what we have to do? We have to run the program. So from 0 to 20, it has created an iteration and it has converted the integer value to a binary digit. Then it is said to be odd or even. So 1 is said to be odd, 2 is even, 3 odd, like that. This is the basic program. Clear? In the next video, we'll see how we are going to find an integer using the bitwise operators. Thank you.